Okay, when you expand any binomial, let's say x plus 4, x plus y to the power 4, you will have the following pattern. Okay, like if you actually expand it one by one, and then you see patterns, and then we generalize it into a shortcut. So this is the pattern that you see. There are three patterns here. Number one is your first term is appear in descending order. x4, x3, x2, this is x1. You don't need to write any power of 1. And then x0 is a 1. That's why you don't see it. And then the second term is y. y0, y1, y2, y3, y4. Again, y0 is just a 1, so you don't see it. y1, you don't need to write exponent 1, and then y2, y3, y4. And then there is a part of the number. There's a number here. 14641. What is that? That is a combination number, NCR. N being your power, so your first term is NC0, NC1, NC2, NC3, and NC4. So for N, when it's 4, there are total 5 terms. So now we try to use this pattern to expand this one. So to power of 6, first there will be 7 terms. Okay, so you draw a line here, 7 terms. It will have the first term in the descending order, 2x to the power of 6, right? 2x to the power of 5, 2x to the power of 4, right? 2x to the power of 3, 2x to the power of 2. Now, when you say 2x, you see put it in a bracket. 2x, you need to bracket the whole thing. And then when you, let's say 2x squared, when you expand it, it's actually 4x squared. This is, the last one is to the power of 0, then it's 1, you don't need to write. The second one is -3. Okay, if the second term has a negative, then it will remain negative. -3 to the power of 0, you don't need to write. -3 to the power of 1, which make the second term negative. -3 to the power of 2, okay, which will become positive. And -3 to the power of 3, which will be negative. -3 to the power of 4, -3 to the power of 5, and finally -3 to the power of 6. Okay, so the result is you have term with alternate sign, positive, negative, positive, negative. Finally, it's a coefficient that goes into it. So what's the combination number? There will be 7 of them, starting from 6C0, 6C1, 6C2, 6C3, and so on. You can put it in a graphic calculator, or if you use a Pascal triangle here, this is all the combination number. Okay, 6C0 is 1, 6C1 is 6, 6C2 is so on. And then it goes here. So 1, 6, 15, 20, 15, 6, and 1. And now you just clean up. Like for each term, you evaluate it, clean up, and then you get your final answer. You rewrite your final answer there. There will be 7 terms. Okay, so this is how you can expand any binomial expression. And then you have a formula which look like this, which is in your formula sheet, will be given. So any term can be find using this method. Okay, let's say you want to find the 5th term. So to find T5, 5th term, your K will be 4, and then you just replace a 4 here, 4 here, 4 here. This is your first term, this is second term, this is a power you raise to. Okay, then you can find any term. You don't need to expand like this. You can just find any term as you wish. Okay, so let's moving on. Next chapter. So the next unit is on radical and rational functions. So 2 kinds of function. Radical function is anything with square roots. That's radical. The graph look like this. It has start from 0, 0, and then go to 1, 1. And it's go like this. It has a starting point. Okay. And then rational function is anything that looks like this, and then it has 2 sides. It has an asymptotes here and there, and then they cross 1, 1, -1, -1. So this is your base function, and then you do transformation from this base function. Okay? All right, describe the transformation of this, and what is the domain in interval notation? Okay, so comparing to the base function like that, I need to rewrite it such that I have a 4, right? Like first take out a 4 from here, x minus, right, like this. Okay, one way to describe the transformation is this is B, this is H, this is K. Then is horizontal compress, right? Like horizontal stretch by a quarter of one quarter, which is a compression. Move to the right by 3 over 4 and move up 2. Another way is after you factor it, the 4 can be taken out on the outside like this. On the outside of the bracket, you have to factor it first and before you take it out. Then this is my A. So H and K remain the same, but it's a vertical expansion by 2. So for this function, a vertical expanded by 2 is same as horizontal stretched by a quarter. You have the same result. Okay, what is the domain then? Now for the original function, the domain is bigger than 0, right? Like look here, bigger than 0 is the domain. So when I compress this by a quarter, the domain didn't change. Okay, it's still, after you do B, it's still 0 to infinity. Now when you move to the right by 3/4, hey, it does change. 3/4 to infinity. You move up, do not affect the domain. So this is the answer. 3/4 to infinity. Okay, in interval notation. You graph it, you also see that. See the answer. Okay, next question is not about the radical function, but it's about performing a square root on a function. So it's a different thing. Okay, it's not radical function. It's an operation. You square rooting a f of x. When you read this question, like some student will not pay attention and then they don't know what the question is all about because you have a function that has such domain and range, and what's the domain of the square root of that? So some student uh, will just didn't see the square root and then don't know what are they asking. Now, when you do this question, you ask, does like how does this look like? A function is continuous from -4 to 16. So -4 is here to 16, -4 to 16. So the easiest function you can see is, let's say it's a straight line from here to there. Does that make sense, right? -4, -4, so it's ranged from, right, -4 to -4, and 16 to 16. Okay, now what's the domain of this function? So the domain of this function will be where it crosses the x-axis, like because when you square root it, it will be something that look like this, right? Starting like 16 square root is 4, right? It's a 4, like it doesn't match line up properly. Like it goes here, it goes in here, okay, and then 4, and then it will has a common point at 1, and then it go through common point at 0 and go through 1. So that it will be something like that. It crosses 0, it crosses at 1, and it reach 4. So I think maybe I copied the question wrong. Maybe it should ask what's the range. Okay, because the domain, you don't know where is the x-intercept, then you can't answer this question. But then for the range, it will go from 0 to 4. The range will go from 0 to 4. That will be the answer. Where does the 4 come from? The 4 come from the 16 being square rooted. And where does the 0 come from? All the negative number, they cannot be square rooted, like they just won't exist. So the y value will start at 0. Okay, so where does the range of the square root is this is the answer. Okay, let's review radical function. So radical function is any numerator over denominator. You can have three situations. You can have a 0, like in the denominator like this, or you can have a 0 on the numerator. Well, this is 0 on the numerator, and or you can have on both, right? So if there's a 0 here, like appears a factor appear on both top and bottom, they cancel out, so they no longer exist, right? So in your graph, that won't be your vertical asymptote, but it will be a point of discontinuity. The point of discontinuity will be at 4. So the restriction here, 4 and -3, the -3 remain to be a vertical asymptote. However, the 4 become a point of discontinuity. And then you plug in a 4 into the x here. 4 plus 5 is a 9. 4 plus 3 is a 7. So it will be 9 over 7. That will be your point. Okay, horizontal asymptote. You look at the coefficient is 1 over 1. So like they have the same degree. So, and then 1 over 1. So the horizontal asymptote is 1. Okay. Here, the restriction is 1/2. Here we go. There's no point of discontinuity. What is the horizontal asymptote? Here, 3 over 2 is a horizontal asymptote. Okay, so this is for when you have two factors, like factors on top, factors in the bottom. Well, how about this one? This one, the top reduces to x plus 2, x minus 2. The x minus 2, x minus 2, they cancel out. So the whole expression is just a linear line. So no horizontal asymptote, no vertical asymptote, because it's just a straight line. But there's a hole at 2, right? Because the restriction here, say x cannot be 2. So this hole at 2, you plug in a 2 in here, 2 plus 2 give you a 4. There's a hole at 2, 4. So if you graph this original equation, you see it's a straight line, but there's a hole at 2, 4. Okay, finally, for this function, can the bottom be 0? No, it cannot. X squared, the minimum is a 0, so plus 1 is 1. So the minimum in the bottom is 1, so there's no restriction, no vertical asymptote. What is the horizontal asymptote? When the degree on top is less than the degree in the bottom, this degree 2, but on top is degree 1, then the x-axis is always your asymptote. And finally, there's no common factor, so no point of discontinuity. Okay, so this table summarizes everything about rational expression, rational equation. Okay, look at this question. Okay, so like we have some function notation you need to work with. So let's take g over f. So solving a rational equation and solving a radical equation. So let's just follow this, what this notation tell you to do. Okay, well, let's move the 3 to the other side just to make it easier to read. Okay, now let's solve it. This over that. Okay. Well, let's like you can move this to the other side, right? X minus 6. Like multiply everything by the denominator. Like this is how I taught it. Like this, minus 90. And then move everything to one side. Make one side 0 because you have a quadratic. So minus 4x plus 6, so minus 84. And then you can use quadratic formula or like whatever way you can like try to graph it and find two solutions. Here that you have two solutions. And you want to check the restriction. Does it meet the restriction? Does it work or not? Is it extraneous root? So this is how you solve any rational equation, which is multiply everything by the LCD. Okay. You may ask, why don't you factor it and simplify this expression? You could, but if you do that, if you let's say you cross out x minus 6, if you could, well, I think you could, x minus 6, you may eliminate a answer because then you only have a linear equation, but as you can see here, you do have a quadratic. You may have two answers, but if you cross it out here, cross out the factor, then you're done with one, a linear, you may only have one equation. So to solve rational, just multiply everything by LCD and keep going, graph it. Here, radical. So if I plug everything in, I have the following, all right? And what does that mean? It means g of f of x. Put f of x into g of x. So f of x is this. And then into g of x is this minus 6. So you have this equation. Okay, how do you solve it? For square root, you just square both sides. So you square both sides, this side equal to this. The other side, you just have a complicated question, square it, and then you keep going, solve it. You can solve it by graphing, you get the answer. Okay, so I will stop it here. I will make another one for the last page.